Hello there, Nareg is here, and today we're going to talk about how to study the variation of cubic functions. Previously, I've been talking about the quadratic function, so this time it will be about the cubic function, but I'm going to repeat again about the steps that you should follow in order to study any function, almost any function. So what are the steps? Let's repeat once again. The first one is to talk about the domain of definition. The second one, regarding your domain of definition, you will have to study the limits. So the second point is limits. The third step is to calculate the derivative. Once you have calculated the derivative, you can directly go to the table of variation. After having a table of variation, you can go to the fourth step, which is choosing some particular points, and these particular points are going to help you to draw your curve. So particular points, this will be the fourth step. The fifth step, you can study the symmetry. Of course, if there's a symmetry, you can study about the symmetry. And finally, at the sixth step, you will have to draw the curve. So these are the steps that you can follow in order to study almost any function. So directly I'm going to take an example of a cubic function and we're going to study them together. So let's start. A cubic function. The function will be f of x is equal to x3 minus 3x squared plus 2. So as you can see, it's a cubic function. In this case, it's a cubic polynomial. Again, the steps are the same. We're going to start by the first step is to talk about the domain of definition, the f, since it's a polynomial, so you will have the f from minus infinity to plus infinity. The next one is to study the limit of x going towards minus infinity of the polynomial x3 minus 3x squared plus 2. Of course, you can choose the highest degree, the monomial with the highest degree. So in this case, you will have to choose x3. You will do the replacement. It's minus infinity to the power of 3. So it's minus infinity. This is for the result. The second one is the study of the limit when x tends towards plus infinity of, again, x3 minus 3x squared plus 2 is again the limit of x tending towards plus infinity of x3. You do the replacement, it's plus infinity to the power of 3, so you will get the final answer plus infinity. Once the limits are calculated, you will have to go to the derivative. So in this case, your function is fx is equal to x3 minus 3x squared plus 2. To calculate f prime of x, it will be equal to 3x squared minus 6x. The derivative of the constant is 0. Alright? In order to study the sign of f prime of x, you will have to say f prime of x is equal to 0, which means 3x squared minus 6x is equal to 0. So 3x as a common factor, you will have x minus 2, which is equal to 0. The roots will be x is equal to 0 or x is equal to 2. And then you go and study the table of variation. You will have to do the table of variation. X going from minus infinity to plus infinity, passing by these two values, which are 0 and 2. F prime of x, it will be 0 in this case, and again 0 for 2. Between these two zeros, it will be the opposite sign of the coefficient a. So I'm going to show you once again. This is the derivative. The coefficient is 3, it's positive. That's why I will have to choose the opposite sign. The opposite sign, it will be negative plus plus. So the function will be increasing, decreasing, and then increasing again. I can also add the limits. So for minus infinity, it's minus infinity, just like we had already calculated. And for plus infinity, it's plus infinity. All right. Now, f of 0 is equal to 2. So in this case, I have a maximum. Which is 0, 2. And the second extremum is for x is equal to 2. F of 2 is equal to 8 minus 12 plus 2. So it's minus 2. The minimum, in this case, you have a minimum. The minimum is 2 minus 2. These are the extremum. Now, once we have finished doing the table of variation, we can also take some particular points. We're going to add these particular points into our graph. So we are going to choose some particular points. Let's get back to our function. x3 minus 3x2 plus 2. So x3 minus 3x2 plus 2. 0, it was already done. F of 1. So I'm going to calculate f of 1. It's 1 plus 2, it's 3, minus 3 is 0. F of 3, it will be 27 minus 27 plus 2, it will give us plus 2. F of minus 1, is equal to -1 to the power of 3. So it's -1 plus 2, it's +1, and then -3, it's -4. So I'm going to check again. -1, -3. So it's -2. In this case, I will have to do the calculations one more time just to verify. So it's -1, -3, it's -4 plus 2, -2. Alright. I can already start drawing out my graph. I can draw the curve. So in this case, these are the values: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. Again, 1, 2, 3, 4, and 5. Alright, so the minimum I will have for 0, 2. So this is the minimum, 0, 2. Sorry, this is the maximum. The minimum will be 2 minus 2, 2 minus 2. So this is the minimum. And then f of 1 is 0. F of 3 is plus 2. F of minus 1, it's minus 2, so it will be a point which is almost here. Since 1 minus 1, it should be a little bit further. I can simply draw my curve, so it comes from the minus infinity. It will pass through, excuse me, I will have to do it again. So this is almost the shape of my curve. Now in this case, this is a cubic function. There are some particular things that we can talk about. The first thing is that since it's a polynomial of third degree, there is a possibility to have 3 distinct roots, and it is the case, of course, in this example. This is the first root, the second root, and the third root. Alright, these are the roots, since your curve, which is in red, is crossing the line x prime o x, x prime o x 3 times. So these are 3 distinct real roots. We can also talk about a symmetry, but there is a center of symmetry. It's not an axis of symmetry, and the center of symmetry is at this position. So from this position you will have a symmetry. Alright. How are we supposed to verify that this point is actually a center of symmetry? It's very easy. We're going to use a certain formula. So this will be our next step. How are we supposed to say that our point, let's say it's I, 1, 0 is a center of symmetry. So the formula will be f of 2a minus x plus f of x, is it equal to 2b? Now a will be 1 and b will be 0. You just have to check the coordinates of your center of symmetry. Let's say I had the coordinates 1, 3. I would have replaced a by 1 and b by 3. So depending on your center of symmetry. Now we can start by saying that this is f of 2 times 1 minus x plus f of x. Will it be equal to 2 times 0? So f of 2 minus x plus f of x, will it be equal to 0? So I will have to again take into consideration my function, and then whenever I have the variable x, I'm gonna replace it by 2 minus x. So let's continue. I'm just gonna check x3 minus 3x2 plus 2. So in this case you will have to replace by 2 minus x, 2 minus x to the power of 3, and then minus 3 times 2 minus x to the power of 2 plus 2 plus x3 minus 3x squared plus 2, will it be equal to 0? So I will have to expand each part. Since the first one is third degree, I will have to use a formula. So 2 to the power of 3 is 8 minus 3 times 4, 12x plus 3 times 2, 6x squared minus x3 minus 3 times 4 plus x squared minus 4x plus 2 plus x3 minus 3x squared plus 2. Again, I will have to verify if it's 0. So I'm going to arrange it. I will have 8 minus 12x plus 6x squared minus x3 minus 12 minus 3x squared plus 12x plus 2 plus x cubed minus 3x squared plus 2. Again, is it equal to 0? So let's start by checking the similar terms. Minus x3 plus x3 minus 3x squared minus 3x squared, it's minus 6x squared plus 6x squared. I can also simplify, reduce them. Minus 12x plus 12x, and then whatever remains is minus 12 plus 8 plus 2 plus 2. Again, is it equal to 0? Yes. 12 minus 12 plus 12 is totally 0. So I was able to verify that the center, actually the point I, which was 0, 1, is the center of symmetry. This is how you will be able to say that this is the center of symmetry. So this was an example about how to study a cubic function, plus we were talking about the symmetry, but in this case it's the center of symmetry. I can also add one last information about the center of symmetry. So the center of symmetry, actually it's called also a point of inflection. This is a point of inflection. How are we supposed to calculate the point of inflection? You will have to do f double prime of x. So we will get back to f prime of x. This is f prime of x. You will have to calculate f double prime of x. So 3x squared minus 6x. F prime of x is 3x squared minus 6x. Once you calculate f double prime of x, it is equal to 6x minus 6. So you will have to say f double prime of x is equal to 0, which means 6x minus 6 is equal to 0, 6x is equal to 6, x is equal to 1. So for x is equal to 1, once you replace in the function, your function was f of x is equal to x3 minus 2 minus 3x squared minus 3x squared plus 3. So once you replace x by 1, you will get, in this case, sorry, once again I'm gonna check my function just to have the exact value, the exact function. So f of x is x3 minus 3x squared plus 2. Alright, x3 minus 3x squared plus 2. Okay, so whenever you're gonna replace x by 1, so f of 1, it will give you actually 0. So you can find the point of inflection, which is again I, 1, 0, and it's also the center of symmetry. So this is how you find the point of inflection. What is the idea about the point of inflection? I'm going to get back to my curve. So there is a change of inflection. Before this point of inflection, the curve is already looking towards this part. After the point of inflection, the curve starts to look towards this part. So this is what you should know about the change which happened due to this point of inflection. Alright, so that's all for this example, which was again about cubic function, how to study cubic function, plus the center of symmetry, point of inflection. I hope it was helpful to you. Once again, you can subscribe to my channel. You will be notified whenever I'm uploading new videos, and of course I can share with you my Instagram account, my Facebook account, and whenever you have any questions, don't hesitate to leave a comment and ask me those questions, or contact me through my accounts. That's all for today. I hope to see you again.